Hello, everyone. Good morning, good afternoon, or good evening. Thank you so much for joining us here today. My name is Carlo Bobilas, Community Manager over on the Cisco Learning Network. If you are tuning in but have not officially registered for the program, I highly encourage you to do so by scanning the QR code on your screen. It'll be a good way to get notified of upcoming live streams and be informed when they are available on demand. Now, I just want to cover the Q&A portion of the live event. We'll be using Slido for these activities, as well as for questions you have during the live event. One important note regarding Slido is that participation for Q&A is exclusively for the live audience. So if you're catching this session on demand at a later time, the Slido QR code might not be active, so just something to keep in mind. If you haven't done so already, you can log into Slido by scanning that QR code on the screen with your mobile device or by logging in directly through our live stream page. So without any further delay, I'd like to introduce Technical Marketing Engineer, Technical Leader Young Lee to give a few words. Young, over to you.
Thank you, Carlo. Hello, everyone. Welcome to another Cisco Learning Network technical webinar. Thank you all for joining. This is our fourth and final installment of a four-part series on Cisco Secure Firewall, threat defense, SD-WAN capabilities, and use cases. In this particular installment, we are going to discuss the integration between the FTD platform and cloud-based security solutions such as SASE and SSE. My name is Yung Lee. I am a technical marketing engineer from Cisco Validated Team. I have the pleasure of Dinesh Magil, who is going to be co-presenting with me today. Also on with us are several of our colleagues from my team, as well as from Cisco Security Business Unit, who are going to help facilitate the Q&A panel in Slido. With that said, I'm going to turn it over to Dinesh to get us started.
Hey, thank you, Don. Thanks, Carlo. Hey, everyone. This is Dinesh. I'm one of the technical leader with the firewall business unit here at Cisco. And today, Dung and I, we're going to walk you through the fourth webinar, which is about integration of the secure firewall with the cloud-based security solution. So today in our agenda, we're going to talk about what is SASE and SSE. So we're going to start with what are the fundamental blocks that comprise of what we know as SASE and SSE today. And then we're going to look into the integration that the FTD provides with Cisco Umbrella as well as Cisco Secure Access. So let's start with this. We're going to talk about what is SASE and SSE, right? So in 2019, Gartner actually introduced a term called Secure Access Service Edge. The intent here was to kind of combine two components. So one is the connectivity part or the networking part with the security part. Now, this means that we're talking about security capabilities like, SWG, CASB, DLP, and the traditional firewalling capabilities as well. Now, the intent here was to kind of combine both the networking and security and help customers define how they can connect and secure their deployments. Now, there are certain deployments in the customer's setup where they might already have invested into their networking infra. And for that, 2 years later, Gartner came up with the term called Security Service Edge, which is SSE. This focuses specifically on the security aspect of the overarching umbrella that is SASE and is talking about secure access to the web, cloud services, and the private applications. Now, the concept here of Cisco of Security Service Edge, which is SSE, is kind of combination of various capabilities. Now, the bottom line is that you have SASE as a whole umbrella, and within that you have security capabilities, which are Security Service Edge, and then you have networking capabilities, which come directly from the SD-WAN deployment. So, from Cisco solution perspective, what's happening is that we've got Cisco SD-WAN, and there are various flavors. You can have Catalyst SD-WAN, Meraki, or FTD. And then on the other side, you have Cisco Umbrella. And when you combine these two components, you get a SASE solution. Now, if compare what does Cisco provide in terms of security service edge, our Cisco Secure Access is the SSE solution, which provides you cloud security. Now, here's a visual representation of what we discussed so far. So we're talking about on the left side, the SD-WAN or the connectivity piece, which gives you secure SD-WAN fabric, application aware routing, performance routing, a unified management view, and the analytics. And on the right, you have security capabilities like Cloud Access Security Broker, Firewall as a Service, ZTNA, or Secured Web Gateway. And these two combine to provide you connectivity as well as security. And this can be augmented with the zero trust capabilities as well. Now, here are some of the key differences between SASE and SSE. So if you talk about SASE, we're combining both the SD-WAN and SSE. And if you're talking about SSE, then the focus is just on the security capabilities, namely features like cloud delivered firewall, SWG, CASB, and in some deployments, you might even see ZTNA capabilities. Now, there's a reference link that will share it with you, and you can go through that to read more about this. Now, where the FTD integrates into this solution is it provides you the SD-WAN fabric, which you can then integrate with the security capabilities on the cloud, whether coming through Cisco Umbrella or Cisco Secure Access. So let's start with Cisco Umbrella. So Cisco Umbrella provides you at a high level a lot of cloud security capabilities. And some of the known ones are it provides you DNS and the web level security and the cloud delivered firewall and some additional advanced capabilities like data loss prevention, cloud access security broker, and is fueled by the threat intelligence information to provide you additional contextual info. Now, this is important because if you have users that are either on the branch or are remote users, as a customer, you want to make sure that you're able to secure access to the users as well as applications. Now, there are two ways that Cisco Firewall integrates with Umbrella. The first use case is the integration with the DNS connector to provide you consistent DNS policy. And the other use case is being able to have a dedicated tunnel with Cisco Umbrella, which we call as SASE Auto Tunnel. So in the first use case, where we use DNS connector, it provides you multi-layer DNS security. What that means is that the users which are sitting behind a branch or a perimeter firewall, they will be subjected to the DNS policies not only on the firewall, but also on Cisco Umbrella. So it provides you double security in terms of DNS. It provides you improved internet performance because now you're not backhauling all the traffic to a hub site. You're actually sending it directly to Cisco Umbrella. And it provides you uniform security policy because if the user is either behind the firewall or a remote user, they're subjected to the same DNS policy evaluation. Now, the other use case is SASE Auto Tunnel. This is where Cisco Firewall allows you to auto-generate a tunnel from the firewall over to Cisco Umbrella. And it also automates the configuration on Cisco Umbrella for the network tunnel towards the Cisco firewall. The outcome being that it provides you secure web and DNS traffic flow going through Cisco Umbrella out to the internet. So this leads us to the common security policy stack, which means that if you have a user, whether they are on-prem or whether they are connected through the VPN to a Cisco firewall, they are secured by any sort of threats that might come on any port or application, whether it's malware, phishing, or C2C attacks. Now, if the same user is now not connected through the VPN or not behind a branch, using the Umbrella roaming module, they're still secured by a Cisco Umbrella, which provides you DNS and web policy inspection. So this way, independent of the location of the user, you have common security policies applied to the users. And this session focuses on Umbrella SASE Auto Tunnel. So let's talk about this. So in this topology, you have branch firewall, which is managed by a firewall management center. And you have Cisco Umbrella, a SaaS service which is available on the cloud. So Now, what happens is that you have Cisco Umbrella pushing in the Umbrella data center information by the virtue of the API integration on the firewall management center. So once the FMC has the information of the Umbrella data centers, it pushes the auto tunnel configuration from the FMC over to the branch firewall. And once the branch firewall is configured to talk to Cisco Umbrella, and that could be any data center based on how you want to set it up, you will be able to access any resources which are either DNS based or web based, and the traffic will be sent through Cisco Umbrella for the evaluation. Now, this gives you a high level view of how the topology would look like, but what if you want to make sure that you have resiliency and redundancy? So for that, we support Umbrella SASE Auto Tunnel high availability. And there are two ways to achieve that. The first level of high availability is achieved on the firewall itself, where you could have multiple tunnels going to same Umbrella data center. And this is where you can even leverage equal cost multipath, which means that you can have as many as 8 active tunnels, which helps you provide redundancy, resiliency, as well as higher throughput. Now, on the right, the other type of high availability that we are talking about is Umbrella DC level redundancy. So on a branch firewall, you could have 2 tunnels, one going to each data center, so that if there are any issues with one of the primary data center, you still have a tunnel to a secondary data center, which will allow the traffic to go through. So now that we understand how it works, let's talk about what are the prerequisites. So in terms of configuration, there are 2 prerequisites. The first one is that from the Umbrella dashboard, admin needs to fetch the API keys, which includes the organization ID, Umbrella network device key and secret, and additional attributes. And once you have those details, these details need to be added on the firewall management center. And once you add those details, then the firewall management center gives you ability to even test that connection to ensure that the API integration is successful before we proceed with the configuration. So now that the prerequisites are all set, the configuration can be divided into 3 steps. The first step is we use the new SASE topology wizard on Firewall Management Center, which allows you to configure 3 things. It allows you to configure the Umbrella data center that you want to connect to, and then it allows you to select the FTD or the branch firewall that you want to use in this topology. And lastly, create a tunnel interface which will be used to communicate to Umbrella. So these are the only 3 things that are needed on the wizard for you to create the topology. Now, once the topology exists, now you go ahead and create an extended ACL and do the routing. This is where you're creating a static route over to the Umbrella data center and create an extended ACL, which is going to be used in the policy-based routing. So essentially, you create the topology, then you have a route pointing to the Umbrella data center so that we know how to reach to that data center. And on top of that, you create a policy-based routing, which essentially says that if the firewall has DNS and web traffic, then send that through the tunnel over to Umbrella. Now, to augment the configuration and troubleshooting, we do have some verification and troubleshooting commands. The commands are available on the FTD CLI, as well as there are some troubleshooting augmentation steps available on the UI as well. So this covers our Umbrella integration, and now we move on to the Cisco Secure Access integration. So before we deep dive into the configuration, let's talk about Cisco Secure Access reference architecture. The goal of Cisco Secure Access is to provide users and endpoints, whether they are managed or unmanaged, access to the resources or the applications independent of where they're hosted. They could be hosted on-prem or behind a data center or on a private cloud. The users can access those resources through the Cisco Secure Access infrastructure, which provides you connectivity as well as security. So if you notice, in the Cisco Secure Access, it has a lot of security capabilities like DNS security, layer 3, layer 4 firewalling, secure web gateway, and a lot more additional security features which are required in the modern networks to ensure that only the legit users and the authorized users are able to access those certain applications and not anything else. So in this architecture, there are primarily two outcomes. The first one is secure internet access, and one is secure private access. This integration specifically talk about secure internet access, although the same integration can be used for secure private access as well. So with this, we take a look at the branch secure internet access use case. So if you recall from our previous webinars, you'd remember that we created SD-WAN VTI tunnel, which is essentially a VPN tunnel going from the branch over to either a public cloud or your head end. So that tunnel can coexist. Now, on top of that, firewall allows you to create an IPsec tunnel with Cisco Secure Access to provide you secure access to your web applications or resources which are either on the cloud or on-prem. These tunnels are today configured manually, and the interface traffic is redirected just like we saw in the Umbrella, even in Cisco Secure Access using policy-based routing. So here's a closer look at how the traffic flow looks like for secure internet access. And now we're talking about web traffic or non-web traffic. And if you notice on the left, you have on-premise where you have the secure firewall, and that has an IPsec tunnel to Cisco Secure Access Infra. And on the right, you have the internet or the SaaS applications. Now, this is where we can either provide active-active or an active backup tunnel. And each tunnel from firewall over to secure access supports up to 1 Gbps. And although if you do want to go beyond, you can use ECMP. And this also supports the overlapping and the outbound NAT scenarios. So similar to Umbrella, let's talk about how does the high availability looks like in this deployment. So there are two types of high availability or redundancy available in this integration. The first one is the redundancy based on the Cisco Secure Access headend. That means that a branch firewall will be connecting to both the primary and the secondary hub. Cisco Secure Access actually has a concept of network tunnel group. So it lets you, as a remote site, connect to Cisco Secure Access, but have two tunnels so that if primary hub fails, then you can still have connectivity to the secondary hub. Now, there might be scenarios where either the data center on secure access is out of rotation or there is outage, and this is where this redundancy ensures that the branch users have still connectivity to the internet or the private resources, whether the primary DC is up or not. Now let's switch to redundancy on the firewall side. On the firewall side, we have two tunnels, so which means that even if one tunnel goes down, you still have another tunnel to send the traffic through. And how we switch from primary to secondary is basically there are two ways. Either you use IKE protocols, timer, and that could be dead peer detection. So basically, you're actually tracking if my peer is available or not. And if it is not, then you're going to switch to the second tunnel. And the other switching parameter is BGP timer. So if your BGP peering goes down, then it lets you pivot to the next BGP pair, which will allow you to connect over the tunnel to Cisco Secure Access. Now, just to summarize, redundancy is based on DPD timeout within IKE protocol or BGP. You can have primary or the secondary hub on the head end for the redundancy. And on the firewall side, you have either active-active tunnels or active backup tunnels. Now, this brings us to the configuration part. And configuration is basically divided into a couple of steps. The first step is that you create a network tunnel group, which is created on Cisco Secure Access dashboard. All right. Once you do that, then you go to the Firewall Management Center and use route-based VPN topology to configure the tunnel going over to Cisco Secure Access. So the first step was gathering the details from Cisco Secure Access, creating a network tunnel group. The second step was creating the VPN topology. And once that is done, then you create an extended ACL, just like we did on Cisco Umbrella. So the principle remains the same. So you create an ACL where you define the DNS and the web traffic. And then you use that ACL in the policy-based routing to define how this traffic will go through the tunnel over to Cisco Secure Access. And lastly, we have verification and troubleshooting commands. And these are quite similar to what we have for the Umbrella. The only difference is now instead of Cisco Umbrella, you can also log in into Cisco Secure Access dashboard to check whether the tunnel is up or if it's not up, and additional stats about the tunnel. Now, there's one piece that I want to highlight for Cisco Secure Access is the fact that it is supported with certain versions, right? So starting with 7.1 and above, you'll be able to create the tunnels manually. And 7.3 and above is where we added the Cisco Umbrella SASE auto tunnel. All right. So with this, I'll hand it over to my colleague Jung back for the live demo. So over to you.
Thank you, Dinesh. Hello, everyone, again. Now I'm going to walk you through the actual configuration of how to create either SASE tunnel to Umbrella or manual tunnel to Cisco Secure Access. So for those of you who have been with us in the previous webinars, you're probably familiar with this reference topology. In this topology, we have two hub sites on the top. We have New York City on the left. We have Newark, New Jersey on the right. They provide internal services to our user at the branches in the bottom. At the bottom, we have 4 branches. We have Providence, Rhode Island, or PRI for short, with a site ID of 71. This is where we're going to use this site to integrate with Cisco Umbrella as part of SASE solution. Next to that is Worcester, Massachusetts, or WMA. Next to WMA is NCT, New Haven, Connecticut. And on the far right is Manchester, Connecticut, or MCT, with a site ID of 74. This is where we're going to focus on to do the SSE integration with Cisco Secure Access. Some additional information right here. Our FMC and FTD are running version 7.6. Let's double click on the first use case, Cisco Umbrella integration, right? So let's talk a little bit about this use case. In this particular POI site, we have a single FTD platform. We have already created the overlay tunnel going to our hub site. For simplicity, we only showing a single hub here, New York City hub. But keep in mind that we also have another hub, the New Jersey hub also. They provide in the internal corporate app and services to the user. We have one internet connection that is go out toward the internet. What we're going to do here is we're going to use the SASE auto tunnel to create 2 IPsec tunnel. Tunnel 1 is going to be the active IPsec tunnel going to one Cisco SIG Umbrella head end, and the other will be the standby tunnel going to a different Umbrella SIG point of presence. Inside of our test network, we have a client located at 10.71.120.100. And this client is configured to support .1x authentication. And in this particular use case, we want to demonstrate the ability to use policy-based routing and route based on security group tag or SGT. So when an employee log in, he or she will be assigned an SGT of 4 from ICE. And based on that, we will construct our routing accordingly. We'll walk through that in just a little bit. And then if we have a guest sign in through a web portal, they will be assigned with an SGT of 16. Now, in our use case, we do not have ICE integration. So therefore, we are using statically defined SGT on the firewall management center. I will show you where to do that. If you have ICE integration, the SGT information will be pushed out from Cisco ICE automatically, and there's no need to define the manual SGT. All right. So for our use case, let's take a look at the policy construct over on the left here. The first construct is if the traffic sourcing from 10.74.0.0/16 going to 10/A, we know that it's going to be internal traffic. And for those internal traffic with a SGT of 4, we also know that is our employee. We will allow the traffic to be routed by normal routing or, topology driven routing. Basically drop out of the policy. Else, if the traffic sourcing from 10.74.0.0/16 that is destined for DNS, HTTP, HTTPS, and with an SGT of 4, we know that it's going to be traffic destined to the internet, and we're going to be routed through policy-based routing to the active tunnel. Should the active tunnel goes down for whatever the reason, that traffic will be routed to the standby tunnel. For all guest traffic with an SGT of 16, we simply route it directly out on the underlay to the internet without any protection from Cisco Umbrella. Also notice that guest traffic will not be allowed to gain access to any of our internal resources. All other traffic that is non-SGT tag traffic will be implicitly fall back to normal routing. All right. So with that in mind, we'll switch over to the configuration and we'll go through the second use case. Now, I will leave it here for just another moment. If you might want to take a screenshot of this for your reference when I go through the configuration. All right. So as Dinesh mentioned, the first step in the configuration is to get the necessary information from Cisco Umbrella. So this is our Cisco Umbrella organization, right? This is the main dashboard when you first log in. Just so you aware, we currently have a couple tunnel already exist here. Okay, we'll create 2 additional tunnel in just a moment. The first piece of information that you need to get is the organizational ID, which you can get it directly from the URL here, as I highlighted. Next, what you need is you need to get 3 additional key and secret. And where do you get it? Is from the admin section, particularly under the API keys. From here, you can go to the legacy keys. Here you can see that we have 4 different keys already created. If you did not have any, you can create it yourself. So the first key that we need is the Umbrella network devices, right? This one is needed for the API integration. When you create a key, you will be given a secret. That secret only shown one time. So you need to copy and safeguard it somewhere because it will not be shown again. And this key is shown here, okay? The next piece of information that we need is the legacy network devices token. And it's shown right here, the token does not have any secret associated with it. And the last one is the management key. This is very important. This is allow us to automatically create the tunnel on the umbrella side. Again, when you create the key, you will be provided with a secret. Again, please copy and safeguard it somewhere because it will not be shown again. Now you can delete it and create a new key, but that's very disruptive if you already have tunnel established and etc. All right. So now with all this information, you can copy it down and then you can switch over to the Firewall Management Center. So let me do that. So this is our Firewall Management Center. As I mentioned, we are running version 7.6.0. This is the main portal here, okay? For our devices, we also run in version 7.6.0, okay? To do the integration with Cisco Umbrella, the first thing you need to do is go to Integration. Under all the integrations, you see that you have an area here called Cisco Umbrella Connection. Now, in preparation for this demo, I already copied all of the information and put it here, as you can see, right? Under the general, you have the organizational ID, the network device keys that you get it earlier, right? And the secret and the device token. Under the advanced, you have the management key and secret. And if you want to implement DNS security or DNS encryption, then you can get the public keys and put it here. We're not doing that, so that's why I didn't put it here, okay? And as Dinesh mentioned, this is very important. You need to be able to test the connection and making sure that the connection is successful, because this is where we fetch the information from Cisco Umbrella, where the data center located, so that we can go through the automation, okay? So this step is done once you test the connection and everything works well, then you can click on say, we already did that, so we don't need to do it again. All right, so everything is looking good here. So let me go back to the device here, just to show you what we are going to do from a device perspective, okay? The device that we're going to be working with is POI device. So let's double click on that. As you can see here, I have Ethernet 1.1, which is our underlay. We call it outside one. We already have two VTI tunnels. These are our overlay tunnel for the SD-WAN fabric. Okay, we have tunnel 1 go into New York, tunnel 2 go into New Jersey. We're going to create two more tunnels here using the auto SASE configuration here shortly, but I just want to show you that real quick. All right. Now, to do that, what we need to do is to create a SASE tunnel, we need to navigate to devices, side to side. Okay, here you can see we have the overlay topology for the SD-WAN. Okay, now to add the SASE tunnel, you can click on add here. You provide a tunnel, the topology name. To keep it simple, we just call it umbrella -sig -topology 1, right? And on the far right here, you can see that SASE topology. You just click that. It's automatically select hub and spoke for you. Okay, we'll just click on create. Here you can see the name. The pre-share key is automatically generated for you, but you can override it. We recommend you just to keep the default automatic generated for you. Here you have the ability to select the umbrella head-end data center. Here you can see these are the available umbrella centers that you can pick from. Obviously, you want to choose the one that closest to your locations from efficiency perspective. So in this use case, what we're going to do is we're going to select Ashburn, Virginia as our first one. Okay. Once you do that, you click on Add. Here you will select the device. We're going to do this at POI side, so we'll select POI. If you already have a static VTI tunnel created, then you can just select it here. We don't, so we'll create one. Here, we'll provide our unique name so we can differentiate from the overlay tunnel. We'll call it umbrella underscore SIG underscore POI for primary underscore SVTI number 3. You need to select a tunnel zone, making sure that your access control policy allow you to be able to get to this tunnel zone. We already have one created, so we'll just simply select it. The tunnel ID, we should leave it at the default generated for you because the system keeps track of how many tunnel has already been created for us. And for the tunnel source, this is where you select your underlay interface, right? So we have one underlay interface and we call it outside one. We'll select that, and because this one is using dynamic IP address, so we simply just select that. Under the IPsec tunnel mode, it will be IPv4, and will provide the suggested tunnel IP address for you. And if you hover on this information piece here, it will tell you, which address range we suggested to you. So we'll keep it the default here, works for us. We'll click on OK. And you can see here the tunnel is created on the device for us automatically. Click on OK. Now we need to provide a local tunnel ID. To keep things simple, we just say POI firewall 01 primary. Okay. We will automatically generate the information when we do the integration here and fill in the blank here. Okay. Click on Save and review the information here. Click on Next. Now notice on the bottom here, it says that deploy configuration on threat defense nodes, meaning that once we deploy the tunnel on the umbrella side, then we'll go turn around and we'll use those information to create the tunnel on the FTD automatically. Click on Save. It will take just a moment, and now you can see that the tunnel is created successfully. And if you click on the transcript here, you can see the information on the API and what the pause means and all of that. Okay, click on Close. Close here. Now you can see here it says deployment pending, meaning that we are still creating the tunnel, deploy the tunnel on the umbrella side first before we creating the tunnel on the FTD side. Okay, so it will take just a few moments. While we're waiting, we can always add the secondary topology. In this case, we'll call it umbrella SIG topology number 2. Again, select SASE. Click on OK. Now this time we need to select a different data center. So we'll scroll down and we'll select New York. Okay, add. Again, select the same device, POI. We need to create another static VTI. So we'll create another one here called umbrella underscore SIG underscore secondary underscore static VTI number 4. Give it a zone. Leave the tunnel ID at 4. Select the underlay interface. and we'll just keep the suggested IP address for the tunnel. Now you need to remember those IP addresses because when we created the static default route, we need to point it to the other end of that tunnel, right? For this, we're going to say POI-FW-01-secondary. Click on save and click on next and click on save here. Again, it's successful. We will close this. And you can see that the tunnel is deployed, but it's not quite coming up yet. You can always hit the refresh key here to get the refresh, but we're not going to wait on here. What we're going to do is we're going to need to go back to the head end here, okay? And if we go to, you can see here, one of the tunnel is already active at Aspen, the first one that we created. The second one is created, but it's still going through negotiations. It's just take another minute or two, okay? Now, let's us navigate it back to our FMC. The next step, what we needed to do is we need to create several different things for our policy-based routing. So for that, let me walk you through that configuration. First, we need to go to the objects. And as I mentioned to you, we are using statically defined SGT. You can define it right here, okay? As you can see here, we already defined two. One we call employee with the security group tag of 4. And the other one is guest with the security group tag of 16. Okay. To create a security group tag is very simple. Click on Add Security Group Tag, give it a name, optional description, and the tag value. Okay. So that is done. The next thing we need to do is we need to create the extended access list to identify the traffic for policy-based routing on the ingress interface. So we go to access list, extended access list. To create an extended access list is pretty simple. All you need to do is click on add, give it a name, and then you can add one or more sequences based on all of these values that you get, we provided to you, can base on source IP, source port, destination IP, destination port, based on applications, based on user that, we also have the ability to route based on the user that we get from AD. We don't have that, or based on SGT. Okay. We already have a couple pre-configured here. One we call Umbrella 6, employee with the security group tag of 4 ACL. So let's take a look at that. For this one, the first sequence here say block traffic that's sourcing from 10.71/16 that is destined to 10/8, and with the group tag of employee will basically drop out of the policy and will allow the topology-driven routing table to route the traffic for us. These would be considered the overlay traffic or internal traffic, okay? The next sequence here is allow. Anything that coming from 10.71/16, we wanted to route anything of the DNS traffic and all of the HTTP and HTTPS traffic with the security group tag of 4 over to Umbrella. All right, very simple. The next ACL here is to identify guest traffic. So let's take a look at that. Now, for the guest traffic, the only thing that we're really concerned about is this SGT here. Okay, if we have a SGT of gas, we simply dump it out to the internet. Okay. All right, so we have the pieces defined already. Now, the next step that we need to do here is we need to create the static routes. Okay, so for that, we navigate back to the device POI. Okay, you can see the two tunnel that we created in the previous step is now up and functioning here, tunnel 3 and tunnel 4. Okay, to create a static route, we navigate into routing, right? And under routing, we have static route here. Now we already have a static route, default route pointing to our upstream ISP for the overlay creation, right? We need to add another route that going out to Umbrella. And we're going to route the first one through Umbrella 6 POI SVTI. And it's going to be a default route. And here you can put the gateway IP address. In this case, we are using 169.254.2.2 is the other side of the tunnel. Or you can also optionally create an object that have this IP address here. Okay, we just keep it simple. We just put the IP there. Okay. Now, the main thing here is that for the metric, you need to specify a metric that is higher than 1 because we already use 1 for the underlay. And in this case, you can use anything higher than 1. Just keep things simple. We'll use a 10. Now, this route will not be shown on when you do a show route. However, we needed this route in order for PBR to work correctly. So we'll click on OK. We need to create another one. And in this time, we are going to point to Umbrella 6, the secondary tunnel. Same thing. It's going to be a default route. And this time, we're going to point to 169.254.2.6 because that's the other end of the secondary tunnel. And again, we need to get the metric higher, right? So we'll use 11 in this case. Right. Now we have our two static route here. We need to save. Okay. Next step is we need to create the policy-based routing. So for that, we go to policy-based routing. We don't have any yet. We will add one. First thing we need to do here is to select the ingress interface. We only have one ingress interface, which we call inside employee. Okay. We'll click on add. Now here, the default is to route out to the egress interfaces. The egress interfaces that we want to route it out of is the two static VTI tunnel that we created here. And we wanted to route it in the order that we specify. So we're going to route it out to Umbrella 6 primary tunnel first. And if that tunnel is not available, then we'll route it out to the standby tunnel. Okay, we need to specify the ACL. In this case, the ACL is going to be the employee traffic. Okay, identify the employee traffic. We click on save. And now you can see that the ACL match, then routed through SVTI number 3, and that not available, then routed through SVTI number 4. We need to add another sequence here for the guest traffic. So again, we need to identify the guest traffic, which is this ACL here. Okay. We also route it out toward the egress interface. And this time, the egress interface that we want to route it out of is the outside one. So we simply select outside one. Now, one note here is that you must have the access control policy as well as the NAC policy that allow you to NAC the internal traffic obtained to a routable address, which we already have in place. Okay, we'll save it. Now you can see now we have two sequences in our policy-based routing. We good with that, then we save it. And then we're going to push it out before we do the testing, okay? Going to push it out. While it's pushing, let's talk a little bit about the client, okay? So we have a client here that located at this IP address, as I mentioned it to you, okay? We have the ability to dynamically assign the security group tag to whoever uses this client, right? And to do that, we can navigate it to here. And if we go to the property here, right, go through the authentication, additional setting, and replace the credential. For the first test, we're going to log in as employee, okay? And we need to provide a valid credential. Okay, now to validate that client is logged in correctly, this is the internal layer 2, layer 3 device that this client is connected to. And if we do a show authentication session interface gig 0/0, the gig 1/0/16, we will see that the IP address is what I just shown you. It is the username is employee. It is authorized, okay? And the important piece of information is right here, okay? It's going to have an SGT value of 4. So everything is set up for that device. Now, before we do any routing out, let's double check to see if our push have been successfully finished. It is completed successfully. We also wanted to double check to see if the network tunnel is up and functioning. Okay, so let's double check real quick. You can see both tunnels are currently active, right? And you see some packet in and packet out is always a good sign. Okay, now let's do one more thing before we route traffic out. You can see now both topology, umbrella topology is up green. Okay, we can also go to overview, side-to-side VPN, and we can look at the first tunnel here, go into Ashburn, right? We'll click on the little eye thing. And if we go over here to the CLI detail, right, we can maximize the view here. And if we expand this, we see some traffic. That's always a good sign, okay? We'll close this one. We'll go to the secondary one. And you can see the secondary tunnel is only does not have any traffic. Okay, all right. So we'll close this one out, right? And now let's us do our test. Navigate back to the client. Now I mentioned to you that we do not allow anything but HTTP, HTTPS, and DNS out to the internet. So let's first test the internal traffic. So from here, can I get to my resources at New York data center, which is 10.100.0.5 is one of the server there. Yes, I can get there. Okay. Let's see if I can get to New Jersey data center, which is 10.200. Yes, I can get there. Let's see if we can get to one of our spoke site. Let's just go to 10.74.120.50, which is our MCT site. Yes, I can get there, right? So everything looks good from the on-net perspective. Now let's see if I can ping out to the internet, which I should not be able to because we don't allow that. How come I can still get through? I thought let me double check. Yep, this one is good. Right. Maybe when I was testing, maybe I still allow ICMP to go through, so for testing purposes. So let's check to see if we can get out to the internet. Yes, we can, right? So RRUMMB. Let's see, we have a policy that will block gambling. Let's see if we can block gambling. And it is, we're blocking gambling here, okay? And let's see what IP address that we are using. And you can see here, we are using one of the umbrella IP address block. And if I navigate it back to here, you can see we are using this block right here. Right? So we are confident that we get the traffic out to umbrella in this use case. All right. So now let's us test the SGT16 to see how that traffic is going to be treated. Right. For that, what we're going to need to do is we need to go back over here and we need to log in as a guest user. In this case, we log in at guest 71. And we'll double check here. Same IP, but now I'm logging in at guest. It is authorized, and we are getting an SGT of 16. Okay, so now let us test for the SGT of 16. We should not be able to get to any of the internal resources, and we cannot. Jersey cannot. And let's try one of our spoke sites. We cannot. We should be able to get out to the internet. And from a traffic perspective, we allow all HTTP and HTTPS, so we should be able to go shopping. We should also be able to go gambling. And we can. And if we look at the IP is coming off of our interface. And if you go back to my slide, you can see that this is our IP address range, 192.133, right? And before we close this, let's go back to the secure firewall and particularly go to the unified event. Go to the FMC, go to the unified events. And if we are looking at the guest SGT here, you can see that guest is being redirected out on the internet on outside to which is our underlay interface. Now we go back in time a little bit here, or let's just do a search on SGT. And if we're looking for employee, we can see that our employee traffic was redirected to Umbrella tunnel, right? Now, if we also go back to the Umbrella side here, and if we go to reporting, activity search, and if we go to all, we can see that the traffic get out from our tunnel to Umbrella. Let's see if I can see some block. Yeah, there are some block that we block back. Okay, so that how we integrate with Cisco Umbrella SIG. Now let's switch our attention over to the integration with Cisco Secure Access or SSE integration, right? So for that, let me switch back to my slide real quick to talk a little bit about what we are doing, and then we'll show that to you, okay? So here we have MCT branch, a single FTD. We already have the overlay established. Again, we only show New York City hub here. From the tunnel perspective, we're going to create 2 tunnels just like we did before. And one of them is going to be active, and the other one is going to be standby, go into Cisco Secure Access. Please note the IP address range here, okay? Now for the policy-based routing piece, we're going to basically say that if any traffic originated from my 1074/16 block destined to 10/8 will drop out of the policy unless the routing takes place normally, right? That would be our internal traffic. Anything else, in this case, we didn't distinguish anything else that other than the on-net traffic, which is basically ship it out to Cisco Secure Access to apply some security policy, okay? Let's switch over to our web interface, okay? Now this is the Secure Access portal. Okay. These are the various connections that we already established here. Okay. So to establish a connection is pretty simple. You go to connect, network connection, and network tunnel group. Okay. From here, you can click on add. We need to create a tunnel group here. To keep things simple, we just call the MCT.FDU-01. Here you have to select the region. Okay, we'll select US Virginia. And we need to select the device type. In this case, it's going to be FTD. We'll click on next. For the tunnel ID, you can use email or you can use IP addresses. We're going to keep things simple. We're going to use the email format, so mct.fw-01, okay, for the name of our device. For the passphrase here, you need to specify up to 16 character, or minimum of 16 up to 64 character long for the pre-share key. Now you can not have any special character. You only can have uppercase, lowercase, number, but no special character. Okay, so in our case, we'll use our right. We go next. Here, from a routing perspective, you have three options. For branch secure internet access, the simplest way to do this is to use NAT outbound only, because we are not servicing any kind of secure private app access. Okay, and this also, if you have overlapping IP addresses, this option is a great option to have. Okay, so we'll keep things simple. We'll just use this. However, keep in mind that you can also do static routing, or if you are doing things like secure private app access, then you can use dynamic routing, in this case, BGP. Okay, we'll save this. Now, once you do that, you will be prompted one time only for your passphrase. So keep in mind, keep that, remember that, right? You can also download that and click on done. Okay, now you can see the tunnel group is created, but there's no tunnel just yet. Okay, now we just download the information here. So we're going to go ahead and open it up, and we're going to use it to create the manual tunnel on the FMC. Okay, we'll keep it there for now, right? Let us navigate it back to our device. Okay, we're going to create a manual tunnel on MCT, so we're going to navigate it to MCT. As you can see, again, we have the underlay interface of gig 00. In this case, it's an FTDV, or virtual platform. We have two overlay tunnel that we created for the SD-WAN overlay already. We're going to create two more tunnel going to Cisco Secure Access here shortly. Okay. The first step that we need to do is to create the topology. So we go to devices, side to side. From here, we'll need to add and give it a name, CSA underscore secure internet access underscore, we'll use dash to be consistent. Coded 1. We need to create a route-based VPN. So we select that. By default, hub and spoke selected. You can do that if you choose to do so, but I'm going to show you a slightly different way to do this. We're going to do a peer-to-peer connection with two interfaces. Okay, click on create. Now, please be advised that we only support IV2, which is selected by default here. And under the devices, we need to fill in node A first, which is MCT. We need to create the static virtual tunnel interface because we don't have one yet. We'll call it CSA underscore secure internet access underscore primary underscore static VTI3. We'll select the tunnel zone. We'll leave the priority as is. the tunnel ID as is. In this case, we need to select the correct interface, which is our gig 00, which is our outside 2 logical name. And because it is DHCP, so we'll select dynamic. Under the tunnel mode here, we'll keep it IPv4. We can keep the IP address suggested. Okay, so we'll click on OK. You can see the VTI tunnel is created on the device, and they fetch the outside interface IP address here, right? We need to send the local identity to the peer. So we are using email, so we'll select email here, right? And this is where we need to get the information that we created on CSA or Secure Access, okay? We'll copy that. We'll put it here, right? We'll add a backup VTI. Again, we need to create a static interface. We'll call it CSA underscore SIA underscore secondary underscore static VTI 4. We'll go to tunnel zone. We'll select gig 0. Okay. Here we can keep it the same IP that suggests, or just for the sake of variety, I'm going to select 3.1 in this case. Remember, this IP is important because later on we need to use like the .2 for the other end of the tunnel routing from a routing perspective. Okay, we click OK. All right, now we need to send the local ID or email again, and then we need to go back to here to get this secondary information. So we complete outside. Now we need to add the other end, which is node B. In this case, node B is going to be external or extranet. We can give it any name we really want, right? So CSA dash US is, for example, dash data center. Okay. Here is where we need to provide the head-end IP addresses that you get on this information sheet here, right? So the first, the primary one, we'll put it right here, comma, and we'll put the secondary. Okay. Now we have all the information about the peer. We need to configure the pre-share key under I version 2, right? We need to select pre-share manual key. Remember the keys that we input, right? It does not show you, so make sure you keep remember that. Make sure hopefully I don't make any typo. All right, for the IPsec, we recommend you to keep the default we selected for you. It works well. Okay, and under the advanced here, pretty much everything is the default, and we can do the do not check here, right? And keep everything else the default and save. Right now you can see that the topology is created, but no tunnel yet because we haven't pushed the configuration. Okay, we need to do that. So here we need to deploy the tunnel. Okay. Now it will take a few moments for the tunnel to be created and coming up. Okay. We're not going to wait. We're going to switch over to another tab here to begin the configuration of the extended access list and policy-based routing. And then by the time we finish, it should be finished enough. Okay. We switch over here. We navigated to devices. And we go to MCT. You can see that the two tunnels are created, but it's not functioning yet. Okay, we navigate to routing. But before we do that, we need to make sure that we have the extended access list created, right? So we need to go to the object management, access list, extended access list. Again, in the interest of time, we already pre-created this access list here. We call CSA-SIA-ACL. Let's take a look. Pretty simple. Anything originated from 10.74/16, which is the IP block that assigned to MCT, that is going to anything 10/A that would indicate that this is internal traffic. We drop out of the policy unless the topology-driven routing table take place. Okay. Anything else that originated from 10.74, then go into anything, we don't care. We just simply dump it out to secure access for additional inspection, if you will. Okay, pretty simple there. Right, so we have the ACL. In this case, we're not going to create a static route because I'm going to show you a different way of doing policy-based routing. You can do the static routing, but I just want to show you a different way of doing it. So we go back to our devices, go to MCT, right? The tunnel is now up. Okay, so that's a good thing. We go to routing. We'll not do static route. As I mentioned, we'll go directly to policy-based routing. Click on Add. There is no policy yet. So we select the ingress interface. Remember, policy-based routing is on the ingress side, right? We click on Add. We'll select an ACL that identifies the traffic that you want to use policy-based routing. In this case, CSA-SIA-ACL. Now, normally you would route based on egress interfaces, right? In this case, I'm going to show you a slightly different way of doing this. We're going to route it to the next hop, okay? What are the next hop? The next hop is the other tunnel in. In this case, we are using 169.254.2. .1 is on our side. .2 should be on the other side. The other tunnel, which is 169.254.3.2, is on the secure access side. We'll click on Save. What we are doing here is we'll send the traffic to the other end of the tunnels, the primary one. If that primary tunnel goes down for whatever reason, we'll go to the secondary tunnel. Okay, we'll save this. We'll save the changes. Now we need to push the changes. Okay, we'll push it. While it is pushing, we'll switch over to secure access. Let's see if we see the tunnel coming in. I will be honest, sometimes it takes just a couple minutes for these tunnels to show up, but you can see here we have a primary tunnel coming in from our IP address destined to the primary data center, and the other one coming in for the secondary tunnel. Okay, so it's always a good sign. You can click on the primary here, and in just a little bit here, when we start sending traffic, you will see traffic here. Okay, no traffic just yet. And similarly, the secondary here, you will not see traffic until the primary fail, right? So everything is looking good here. Before I showcase the testing, let us also go to the access policy here to show you the access policy. We have a very simple access policy here. The first rule saying that anything coming in from MCT side number 74 that destined to the internet, we have a couple block. We basically block the gambling sites. This is part of the URL filtering, if you will, or secure web gateway, if you will. Then the second block, we say anything coming in from our MCT site 74 that is destined to A.A.A.A, we'll simply drop it, then allow everything else, just to show you the power, right? Right? So you can see that right there. Now, for testing purposes, we are using this client here. And as you can see here, the client is 1074.120.50. And first, we need to test the on-net traffic, right? So if I can go to my 10100, which is New York, 0.5, which is one of our server, yeah, I can get there. And if I can go to 10200, that would be New Jersey, right? And see if I can go to 10.71, which is POI location, 120.50, which is the client that we used testing earlier, okay? So everything looking good from the on-net perspective, right? Now we say that we block ping to A.A.A.A. Let's see if that works. It looks like it is, right? I cannot get out. Let's see if we can ping to A.A.4.4. And we are successful, okay? Or any other destination, doesn't matter, right? Ping cisco.com, for example. Okay. Now let's test the secure web gateway blocks, right? So can I go shopping? Yeah, I can. Can I go to buy a car? Buy American made, for example? No problem. Can I go gambling? No, I cannot, because we block gambling, okay? So what IP address are we using? We are using one of the IP blocks for Cisco Secure Access, 151, okay? So everything is looking good from that perspective. Let me show you a couple more things and we'll code it good. If we go back to Secure Access, and if we go to Monitor, Activity Search, we can see traffic coming in from MCT, right? Allow traffic as well as block. Let's see if we see any block. And yes, we go to bet. We bet 365, we got block. We try to ping, we got block. Okay. Now, let's go one more thing and then we'll code it good. Okay, everything looks good. All right, we'll go to the overview. We go to side, right? And we go out to the tunnel. We go to CLI detail here, right? We can see that packet encrypt and packet decrypt, right? That's always a good thing. We go to the second one. You can see that it's idle right now. All right. So with that, we want to conclude this demo as well as the webinar. Before I say my goodbye, I want to say thank you again very much for your attendance. We hope you found this to be informative and hope to see you again in future webinars. Carlo, over to you, sir.
Awesome. Thank you very much, Young, and thank you very much, Dinesh, for this great session and sharing your knowledge and expertise with our audience. I did see a couple questions come into the queue. The main one was if the session will actually be recorded. And yes, this session is being recorded and will be made available for playback, I believe, immediately. So you can actually view that after the session ends. The post-event discussion thread is listed. I believe it's a QR code on the top right or bottom right corner of the screen. So definitely scan that, bookmark that. We'll upload a copy of the slide deck as well as a downloadable PDF for your review at your leisure. All right. So let's see if there's any other questions that came in. Dinesh, I know you answered a couple here, but we can go ahead and highlight one of them. One of the questions asked was, as Umbrella is being phased out, will this FTD integration with SSE be on the Cisco Secure Access? You did answer, and you said yes, Secure Firewall will support direct integration with Cisco Secure Access without having to create manual tunnel in future releases. So thank you very much for that.
So just to add on to that, currently Cisco like Umbrella allows you to have that automated tunnel integration today, right? And with Cisco Secure Access, what Dunk showed us was the manual configuration. But in the future releases, we will include the API integration where you don't have to do that manually.
Gotcha. Awesome. Thank you very much. I think that does it for our questions. Dinesh, do you have anything else you'd like to say? And then we'll move on to Young to close it out.
Nope. So just want to clarify that we've just concluded all the 4 webinars, which kind of cover everything that Cisco Secure Firewall covers on the SD-WAN front. So it's a full live demo that Dung did for the last webinars. So we highly encourage everyone who is attending to kind of test it out. Let us know what works, what does not, and we can definitely take some feedback.
Young, how about you?
No, just thank you. And, we hope, again, these webinars are useful to the audiences. And as Dinesh say, kick the tire, test it out, provide feedback.
Awesome. Thank you very much. And just to add to that, the post-event discussion thread from today's session, again, that's a QR code that you can scan. And when you're directed there, we actually will link all previous post-event discussion threads from all 4 sessions. If you look towards and scroll towards the bottom, you'll see a resource section and it'll list all of the links there. And each of those post-event discussion threads, you can continue the conversation, ask questions, and so forth, along with view the recordings, as well as the downloadable PDFs that you can review as well. Okay, well, thank you again very much, Young, Dinesh, for a great session. But before we do wrap up, I wanted to take a moment to cover some quick items. Just launched the Slido survey, and for those that have tuned in to Slido, we would be so grateful if you could take a moment to complete it and let us know how you like today's presentation. We always look forward to receiving your valuable feedback. Thanks again to our presenters and to all our attendees for joining us live today. I hope that you all have a great day, and we will see you next time. Thank you.